Okay, we have here another interesting integral. We've got the integral from 0 to pi over 2, cosine 2x, cosine 4x, cosine 6x, dx. I got the idea from this recently. I did a video from the MIT integration bee. We just had it was just like this, but we had all odd coefficients instead of even. I did complain a lot in that other video because these can be kind of a pain, but what we can do here, the thing is, it's all about the even coefficient. The reason is, let's look at a simpler integral. We'll look at let's do something like this, where n's going to be an integer, so that way we know this is going to be an even coefficient. If we integrate this, we're going to get sine 2nx, the 2n's going to pop out, but the constant isn't really going to matter. When you evaluate this, what's going to happen is the 0, sine at 0 is 0. You plug the pi over 2 in, you're going to get an integer multiple of pi inside the sine. That's also going to be 0. So this thing, regardless of, as long as the n's an integer, this is going to be 0. Now, if we look at our angle difference formula for cosine, if we've got two different cosines, we'll just say, let's just do this quick. Cosine A, cosine B, this is going to be 1/2 cosine of the sum of the angles plus cosine of the difference of the angles. Now, what's going to happen when we always have even coefficients? When you add an even integer, you subtract even integer, you always get back an even number. So this is always going to be in the form of this. So what's going to happen is every term we're going to get, even though we have to do this multiple times, they're all going to be in this form. So we can jump to a solution of 0. But there is one little thing we need to check on this. We're not worried about negative n, right? Because cosine's an even function, but what happens when n equals 0? Well, if we do that, then here we have the 0 is going to zero out everything. So we're going to have cosine is 0, which is just 1. Now we're going to be integrating 1. Sorry, we're going to be, not that, we're going to be integrating 1 from 0 to pi over 2. You integrate that, and what you're going to get is just going to be pi over 2. So what we need to do is we need to kind of hold off on our answer for a second, because we just need to make sure we don't have any of these n equals zeros. If we can verify that they're all non-zero, the whole problem's 0. If one of them is, if any of them are going to be an n equals 0, then we know it's going to be pi over 2. Now for the reduction on this, I'm going to do it really fast and tell you what I'm doing. So for 3 cosines, for 2 cosines we saw we pull a half out. For 3 cosines we pull a fourth out. For 4 cosines, it would be an 8th, 16th, etc. So we know the pattern of the constant that's going to come out of this. Here it's going to be 1/4 for 3 cosines. And then what we're going to get for this is we're going to get this many terms out of this. We're going to get 4 terms, and it's going to be every combination of the angles. So like for the first one, we can just add the angles, and we get cosine 12x. Then for the next one, I can take these two and subtract off 2. So 10 minus 2 cosine 8x. And then I can go cosine 8x minus 4 cosine 4x. And then last, I can add these two, cosine of 2 plus 4, 6x minus 6x, but that's going to be like cosine 0x. So this right here is going to be the n equals 0 case that we were just talking about like 5 seconds ago. Everything else is the case we saw before, that it's going to 0, going to 0, going to 0. This goes away. Now I forgot my bounds on this, but this integral when n equals 0, we just found that that's when the whole thing's 1. So the whole thing, the value is going to be pi over 2. We have our constant in front, 1/4. Multiply it out for my final solution on this, we just get pi over 8, and that's it. Okay, so there you go. The even case is a lot more fun. I was in kind of a bad mood for the other one. No one likes dealing with odd numbers. I guess an interesting variation on this, if we change this, I think if you just do, if you do cosine 8x there, then now this one is going to be 0 because you're not going to get the n equals 0 case. I don't think there's no way to get a n equals 0 out of this combination. No, not possible. So you could do a slight variation and you get the 0. So anyway, that's it for today. Thanks everyone for watching. Have a good day.